Okay, so number 29 in the August 2022 Regents. This is just basically giving you all the information that's down here. And if you look at this big triangle right here has a right angle at A, and then these two right triangles have a right angle here, and then there's another one right here. So this is Mickey Mouse. When the big triangle has a right angle, and then these two little side-by-side triangles have right angles, that's Mickey Mouse. Okay, so then let's just look at what it says here at the bottom. The length of DL is 4 times the length of BD. So this is 4 times whatever this is. Okay, now here's the thing. I don't know what that is, so I'm just going to call that X. But I know that DL is 4 times that, so I would write 4X like that. Okay, and then hopefully you see that for Mickey Mouse, this would be the nose. Okay, so when we write this, we always write it as a proportion. And the thing inside the loop here, which is the nose, gets written twice diagonally across from each other. So 6 and 6. And then the two whiskers get written diagonally across from one another. So remember, this is a whisker and that's a whisker. So now all I'm going to do is cross multiply, and I'm going to get 4x squared equals 36. I'm going to divide by 4. X squared equals 9. And then to get x by itself, I take the square root, and that's 3. Now, just be a little bit careful because I haven't even read the question yet, but that's saying that this right here is 3, and then this right here is 4 times 3, which would be 12. Now let's read what it says. Determine and state the length of BD. Okay, and BD is just that right there. So your final answer is X equals 3, or you could say BD equals 3. That's up to you. Okay. All right, so we got a lot going on here. I'm going to start with just this first. Well, actually, let me back up. I looked down here, oops, and actually I put 35 here because that's angle DAE. DCE goes here, and I forgot about NEC. So let me go NEC is 30. Okay, well that gives me something to go on here. Okay, I know all the angles in a triangle add up to 180. So if this is 30 and this is 25, I would add those up. That would give me 155. And then I would subtract that. I'm sorry, that would give me 55. And then I would subtract that from 180. And that will make this 125. Okay, now I also know that if this angle here is 125, this one next to it would be 180 minus 125, right? Because these two angles are on a straight line. So they add up to 180 degrees. So that makes this thing 55 over here. Okay. Now, the other thing I know is they did tell me that we had a trapezoid here. So that means that this line up here is parallel to this line right here. Okay, and then we have a transversal, not that you need to know what that is called, but what you do need to know is if this is 25 all the way down here, then up here is also 25. And that's the only important part that you really need to take out of that. So don't worry if you don't remember transversal. Oops. Okay, so I'm going to put a 25 right there. Now, the other thing is if this is 30 degrees, this guy right here is also 30 degrees. These guys are vertical angles. Do you see how these two lines intersect? And they kind of make V's. This V is equal to this V. Okay, so this is 30 degrees. So these guys are the same. Now, if I know that, I can kind of do what I was doing down here. If this is 25 and this is 30, these guys add up to 55. Subtract that from 180, and that will give me this angle right here. Okay, so that is going to be 125. And then the one next to it is going to be 55 for the same reason as what we did down here. These guys add up to 180 degrees. Okay, I'm just coming up with stuff. I'm just trying to come up with everything and anything I can think of. I'm not even really answering the question. Okay, so then if I keep reading, it says we've got diagonals intersected E. Here we go. AD is equal to AE. I'm going to put that in red so you can see that. So AD here is equal to AE. So what you should take away from that is the fact that this triangle ADE, see this triangle right here, is isosceles. And what that means is that these two bottom angles here should be the same. Because if these two sides are the same, the two bottom angles are the same. Okay? All right, so let me just go back because this does not look like a 3. That should be a 35. So if I do 180 minus 35, that's going to give me 145. And that 145 is going to get split into these two angles right here. Okay, so each of those, I know that's going to be ugly, but each of those are 72.5. And then this one is 72.5, which means then this angle here and this angle here are equal because they make V's with one another. So this is 72.5. Okay, do you see? I just keep trying to come up with everything and anything I can. Okay, just using basic geometry rules. All right, so then I see I've got a straight line here. So I know that that should add up to 180 degrees. So if this part here is 72.5 and this part here is 30, if I add those two up and subtract from 180, I'm going to get this part right here. Okay, so again, I'm going to add 72.5 plus 30. So that's going to give me 102.5. And then I'm going to do 180 minus that 102.5. And when I do that, I get 77.5, which means this is also 77.5. Okay, so once I have almost every single angle in the picture, then I kind of tend to read what the question's asking. And it says, determine and state the measure of angle ABD. All right, so ABD is this angle right here. Okay, well, that is in this triangle right here. And we have two angles in that triangle. We've got 77.5 and 55. So hopefully at this point you kind of know the drill. So I'm going to do 77.5. I'm going to add 55 to it. Okay, so that's 0.5. This is 12. So that's 132.5. And then I'm going to do 180 minus that 132.5. And that will give me this angle. And that ends up being 47.5 degrees. And there you go. So we're finding the area of a sector, which basically, if you recall, the formula is area equals the arc over 360 and then times pi r squared. Okay, all right, so I know that this angle right here is 36. So that means the arc that it opens up to is double that because the vertex is right here on the edge of the circle. Okay, so let me kind of say, if the vertex was at the center of the circle, I'm making this up. If this was 50 degrees, that would be 50 degrees because the vertex is at the center. But when the vertex is at the edge, this is half of this arc AC. Okay, so we just double it. So that's going to give this as 72, and this one will also be 72. Okay, all right, so then all we have to do is area equals 72 over 360 pi, and they give us the radius, it's 4 squared, and you just throw that into your calculator. Okay, so that's 10.0530, and it says to the nearest tenth. This is the tenths place. That 5 is going to bring it up. So that's 10.1 inches squared. All right, this, I will admit, can be tricky, but if you can just come up with a couple of little methods or ways to deal with the trick, it won't be bad. And you're very good at SOHCAHTOA, so I think that we got this. All right, so it does ask you, I'm looking below the picture, and it says determine and state to the nearest meter the height of the tree. So what I want you to basically see is we are looking for that then. That's the height of the tree. Okay, so we've got a lot of triangles going on here, but we have to only look at the right triangles. Okay, so for example, I have this right triangle down here. The only problem with that is I don't have any of the angles in there besides the right angle, which doesn't count. And I just have this side, that's it. So I only know one side. So this may not be so helpful to us. Okay. Now, then I'm going to look at this triangle right here in the middle. And please look at it super careful. This is not a right triangle. That's not a right angle. This is not a right angle. And this is not a right angle. So we're not going to look at this either. Okay, so let's look at this top triangle. That's a right triangle. Do you see it? Okay, that's a right angle right there. And we have an angle measure. Okay, now we have one more triangle that I want you to look at. Look at, and you know what? Let me highlight it. It'll be a little bit easier to see, I think. We're going to come along here. Then we're going to go all the way up to the top. And then there. Okay, so if you can recognize those two triangles, I'm going to take it out of context. So the one that I just highlighted in red, so I just drew the two triangles and took them out of context of the pictures. So this blue one here is this blue one down here. So you can see this is the angle of 13.3. Okay, my right angle's over in the corner here. And I don't have anything else here. All right, so then I had highlighted this red one right here. So this 22.2 degrees is right here. Again, there's my right angle here and here. And I want to talk for a minute about this 50. If the height of the building is 50, then that means this whole length here is also 50, right? Because basically you have a rectangle here, if you can see that. So if this is 50, that whole thing is 50, which means this whole thing is 50. So I am going to put a 50 right there. Okay, so now if this whole thing is 50, if I could find this part right here, okay, which is this blue part right here, so I'm going to repeat it again, from this corner to T. Do you see that that's this blue piece right here? If I found out that that was 20, then I would just do 50 minus 20, and there's the height of my tree. So that's my game plan. My game plan is to find this blue piece right here, which I'm going to call this X. No, I'm not going to call it X because we already have X for the tree, so I'm going to call that Y. Okay, and if I find Y, then I know that I'm set because I just have to subtract it from 50. So here's the thing. The other game plan that you have to really kind of look at here is currently as is, I cannot find Y. I need something else here. And I don't know what this is. That's the length of this side. And I don't know what this is. That's the length of this side right here. But do you notice that the length of this side here is highlighted in blue and red? So it is the same side that is here and here. And this I can find because I have 50 and I have 22.2. So I'm going to call this Z, and then I'm going to look at this red highlighted triangle, and I'm going to say, what do I have? Sine, cosine, or tangent? Okay, and so if I look at that, I look and I say, well, I have adjacent and I have opposite, so I'm going to do tangent. So I'm going to do the tangent of 22.2 equals the opposite over the adjacent. Cross multiply, and I get Z times the tangent of 22.2 equals 50, and then I'm going to divide out that tangent of 22.2 to both sides. Okay, and then Z is going to end up being 122.5212. Now that's not the final answer, so I am not going to round that. But so then I know that this side up here is 122.5212. Okay, which means this is 122.5212. And now, so this is what I did right here. This is what I did first. Now I'm going to move in this direction. And I'm going to look at this blue triangle and I'm going to say, all right, well, I have adjacent and I have or need to find the opposite, right? So then I'm going to do the tangent of 13.3 equals opposite over adjacent. And I'm going to put this thing over 1. And I'm going to cross multiply. Now this is nice because that just cross multiplies. You just throw that right in your calculator. And I will get y equals 28.9627. Okay, now this is not the final answer, so I'm not rounding it. But let's just take a look at where y is. So y is this blue piece right here, right? So let's find it up here. Y is this blue piece right here. Okay, so that right here is the 28.9627. Okay, so then the goal is to take these two and subtract them. So 50 minus 28.9627, and that ends up giving us 21.0372. And that is the height of the tree. Now we just need to round that to the nearest meter. So that would be 21 meters would be the height of the tree. Right, so number 33 wants you to prove that HYPE, hype, is a rectangle. So this is the definition of a rectangle right here. So I'm going to prove it's a parallelogram with a right angle. So parallelogram, opposite sides are parallel, and a right angle, you can pick any one of these four, and we want to prove that we have a right angle. I'll discuss that when we get to it. So I'm going to start with the parallelogram part. So I'm just going to do 4 slopes. What I am going to do is I'm going to kind of group them together. So for example, I know that HY should be parallel to EP. So I'm going to do those slopes together. Okay. And then I know that YP, oops, let's get that out of there. I know that YP should be parallel to HE. So I'm going to put those two together. Okay, and I'm going to do the slope formula for all 4 of those. So why don't you pause me and go ahead and do the slopes, and then unpause and check your work. So I know these guys have the same slope. Okay, so that I know that HY is parallel to EP because they have equal slopes. Okay, now you can say it in a different way, but you want to say the same thing. Okay, I'm just kind of cutting to the chase here. So if I look at these two, now if you notice, I simplified these. You can put it in the calculator and it'll reduce it for you. There's a reason why I did that. And hold on, and I will show you. But in the meantime, so then I know that YP is parallel to HE for the same reason, because equal slopes. Okay, so what that does is that makes HYP a parallelogram, okay, because opposite sides are parallel. There you go. So we just proved the first part of this coordinate geometry proof. It's a rectangle. We haven't proved that part yet, but it's a parallelogram. Now we have to prove the right angle, but we just proved the parallelogram thing. Okay, now the right angle. Eeny, meeny, miny, mo. Just pick any right angle. So let's say I pick H. Okay, so if I pick H, then I know HY and HE are the two sides that make that right angle. Okay, so I'm going to write those two sides down below. So HY and HE are the two sides that form angle H. And I am not reinventing the wheel here. All I'm going to do is go up above and I'm going to say, oh, HY slope, 3/5. HE slope, -5/3. And I'm just going to rewrite it. So I've got 3/5 here and I've got 5/-3 here. Okay. This is why I reduced these or simplified them, because it's very easy to see here that this one's negative and this one's positive, and these are reciprocals of each other, 3/5, 5/3. So these guys are negative reciprocal slopes. It would be harder to see that if you had like this one and this one. Okay, so I just tend to reduce it. All right. So I'm sorry, let me repeat that again. It would be harder to see that if I had this 3/5 and this 10/-6, this one and this one. It's hard to see that those are not negative reciprocals of each other, but if this is simplified, it's easier. Okay, so then the explanation is the slopes are negative reciprocals, so HY is perpendicular to HE, and then there would be a right angle at H. Okay, and we already stated this up here. A rectangle is a parallelogram with one right angle. Here's the parallelogram part. Here's the right angle part. Done. Okay, so I started with making a box, and it says a packing box for baseballs is in the shape of a rectangular prism. And I put the dimensions there. So when I look at this right away, I say to myself, we have a problem because I don't want 18 inches. Okay, so I'm going to turn that into, I'm going to read the rest of this actually. Okay, each baseball has a diameter of 2.94 inches. So I'm guessing then, I'm just going to keep reading maximum number of baseballs. And then down here, look, per cubic inch. So everything else seems to say inches. So I know, and I'll put this in red, 2 feet. Well, there's 12 inches in 1 foot. So that would be 24 inches, right? In 2 feet. And then 1 foot here, this would be 12 inches. So I'm going to use 18 inches, 24 inches, and 12 inches, if you're following what I'm doing. Okay. Okay, so what we're doing is we're packing baseballs into this box that I have over here on the right, right? So I want to figure out how many baseballs I can go along here, and then how many baseballs I can go along here. They tell me the diameter of each baseball is 2.94 inches, and I need to get to see how many 2.94 inches, in other words, how many baseballs I can fit into 24 inches. Okay, so what I did was I essentially took 2.94 and I wanted to see how many of those went into 24 inches. Okay, and when I did that, I ended up getting 8.163. Then I did the same thing. I want to see how many of 2.94 inches, aka a baseball, the diameter of the baseball, goes into 12 inches. And when I did that, I got 4.0816. Okay, so this is telling me roughly 8.163 balls. Now, obviously, I can't have 8.16 of a ball, so I'm going to say 8 balls. I have to round down, and 4.0816 balls. Again, I'm going to round down. So I want you to look at what I drew right up here. This is like a bird's eye view. So I'm like a bird flying in the air and I'm looking down at the box. So I'm looking down here and I'm seeing the base that's down there. So what I really just found out by doing this is along the 12-inch side, I can fit 4 balls with a little bit of space left over. Okay, so it's going to look something like this. 1, 2, 3, 4 balls. And then going in this direction, I can fit 8 balls, but I can't fit 9. So 8, and I'm going to have some space. So I already have there 1, so 2, 3, 4, 5, 6, 7, 8. You follow? And then, I could fill this in and we could just keep going all the way across. So if I have 4 going this way and 8 balls going this way, okay, hopefully you can see that that would be 8 times 4, which would be 32 balls. Okay, all right, now let's take a minute and let's read what the question's asking, because it says, determine and state the maximum number of baseballs that can be packed in the box. 32. Okay, along the bottom of the box. What I'm not taking into account is that I have a height of 18 inches here. Okay, so each ball essentially has a height, aka the diameter, of 2.94. So I'm going to just draw this. So from here down to here, that distance right there is 2.94 inches. Well, this is more than 2.94 inches, isn't it? So I want to figure out how many balls I can stack on top of one another. So I'm going to do the same thing that I did over here. So I'm going to do 2.94, and I'm going to divide that into 18 inches. Okay, and when I do that, I get 6.122 balls. Okay, now obviously my drawing is not drawn to scale, but what that's saying is I can have 6 stacks working up. So this is just the bottom of the box, but I'm going to have this plus 5 more stacks, so a total of 6 stacks altogether. Okay, so if there are 32 balls on the bottom stack, okay, so 32 balls, right, on this bottom stack here, but we have to take into account we can fit 6 more balls working our way up. So that would be 32 balls times 6, and that will give us a total of 192 baseballs. And there's our answer to the first part of the question. All right, the second part of the question says the weight of a baseball, that would be one baseball, is 0.025 pounds per cubic inch. So it says determine and state to the nearest pound the total weight of all the baseballs in the fully packed box. What I'm going to start by doing is finding the volume of one baseball. So if I take the volume, I'm going to write BB for baseball, of a baseball, right? So that's a sphere, 4/3 pi r cubed. Well, I know that the diameter is 2.94. So if I take that and I cut that in half, the radius would be 1.47. Okay, so in here, then I'm going to do 4/3 pi, the radius 1.47, and I'm going to cube that. And then just throw that in your calculator. And I'm going to get 13.3057, and that would be inches cubed. Now that's the volume of one baseball, okay? So this is the volume of one baseball. How many are there? There's 192 of them. So I'm going to take this 13.3057 and I'm going to multiply it by 192 because there's 192 baseballs. So that will give me 2,554.7133 inches cubed, and that's for 192 baseballs. Okay, now if we read the question, it says the weight of a baseball is approximately 0.025 pounds per cubic inch. Okay, so then what I'm going to do is I'm going to multiply by 0.025. And when I do that, I get 63.8677. And it says we are going to round that to the nearest pound. So that's going to be 64 pounds. Final answer.